Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue with the next lecture 4 of 5 for the third subtopic, which is differentiation of exponential and logarithmic function. So for this lesson, students should be able to find the differentiation for exponential and log function, which is e to the power of x and then e to the power of a function of fx. And then for the logarithmic function, students should be able to differentiate, to find the differentiation, the natural log of x or and natural log of a function f(x). Okay, so let's move on. So derivative of exponential function. For the simplest exponential function e to the power of x, so directly the simplest form of exponential here, we will directly get exponential of x itself. Okay, so we don't have to change anything, just copy back the function e to the power of x. If m is a scalar, d of dx, the derivative of e to the power of m multiplied by x, what we need to do is to bring the scalar m as the coefficient of the exponential. So the answer will be m e to the power of mx. Okay, so this is if we have a scalar in front of the x. Okay, next, for the general exponential function e to the power of fx, so we have a function of fx where fx is a function of x. The derivative is given by, so it will be f prime x multiplied with the exponential itself to the power of fx. So what we need to do is just to copy back the exponential itself, but we need to multiply it by the derivative of the power. The power here is fx. So we have to differentiate f with respect to x. That's why we get f prime x. Okay, so this is the formula if we have a function at the top of the exponential, not only x. Okay, so let's see some examples. Oh, sorry, this is the proof. By using the chain rule, let's say we have a function of y in terms of x where it's equal to e to the power of f of x. Then, if we let u equal to the function fx here, so y is actually equal to e to the power of u. Then, if we apply the chain rule, we have to differentiate u with respect to f with respect to x, which is f prime x. So, we have fx here, differentiate it, we get f prime x. And then for y, we need to differentiate with respect to u. So, dy du is equal to e to the power of u. And then to find dy dx, we use the chain rule formula. It will be dy du multiplied by du dx. So this is the chain rule formula. And then what is dy du? Dy du is equal to e to the power of u. Du dx is f prime x. Okay, so e to the power of u multiplied by f prime x, where e to the power of u is actually fx. So the answer will be dy dx equal to e to the power of x fx multiplied by f prime x. Okay, that's why the derivative of e to the power of a function fx is equal to the e to the power of fx itself and then multiply with the derivative of the power, which is f prime x. So let's see example. Find dy dx of the following. The first question here, we have e to the power of 2x. And then we have 7 e to the power of 5 minus x squared. And then we have y equal to 2 or divided by e to the power of 3x. And lastly, y equal to e to the power of square root of x plus 1 plus e to the power of x squared. So let's see one by one. So for y equal to e to the power of 2x, so directly we can, okay, so we copy back the question because it's an exponential. Everything we need to do is to copy back the function itself. So dy dx is equal to, copy back the function e to the power of 2x. And then what we need to do is to multiply with the derivative of the function, the power here, which is derivative of 2x, which is equal to 2. So differentiate 2x respect to x, we get 2. So the answer will be 2 e to the power of 2x. Simple, right? So for question B, so we have y equal to 7 multiplied by e to the power of 5 minus x squared. So this 7 is just the coefficient. So we just can take out the 7, or just let the 7 in front of the e, and then we need to copy back everything lah. So copy back everything for the exponential. And then what we need to do is to, yes, we need to differentiate the power here. So differentiate 5 minus x squared. What do we get? So differentiate 5, we get 0. Differentiate x squared, we get 2x. But here we have negative, so it will be negative of 2x. And then simplify everything. What we have for the answer, don't forget to multiply the 2 with 7. So it will be negative 14x e to the power of 5 minus x squared. So this is for B. How about C? So y equal to 2 over e to the power of 3x. So this is a division between two terms. But because 2 is just a constant, we don't have any x here, we can assume that, oh, this is only a constant multiplication of 1 over 3x. 1 over e to the power of 3x, sorry. Okay, and then we also can apply the rule of indices here. So it's actually equivalent to, yes, e to the power of negative 3x. So 1 over a to the power of n is equivalent to a to the power of negative n. So we have a negative in front of the 3x. So now we can differentiate it. So 2 is just a coefficient. So copy back everything. So dy dx is equal to 2e to the power of negative 3x. And then differentiate the index here, the power here. So differentiate negative 3x. So what do we get for differentiation of negative 3x? Yes, it will be negative 3. So don't forget to simplify everything. Multiply the constant, these two constants. So we have negative 6 of e to the power of negative 3x. Okay, for D, y equal to e to the power of square root of x plus 1 plus with e to the power of x squared. So we have 2e here, and it's combined by plus addition. So we can use the sum rule. So we can differentiate each of them separately. Okay, now to differentiate e to the power of square root x plus 1. So we just copy back everything, and then we need to differentiate square root of x plus 1. So differentiate square root of x plus 1, and then plus with, so summation rule, plus with, so we differentiate the second term, so we copy back everything. So we have e to the power of x squared, and then multiply by the derivative of the power. So derivative of x squared. Now what we need to do is to solve the derivative part here. So how to differentiate square root of x plus 1? So what is this square root? This square root is actually, yes, it's a power of, so derivative of square root of x plus 1 is equivalent to derivative of x plus 1 to power of 1 over 2. So how to differentiate this one? We have to apply the general power rule. So we bring the power as the coefficient. That's why we have 1 over 2 here. And then copy back everything inside the bracket. And then the power should be minus 1. So 1 over 2 minus 1 will be negative 1 over 2. And then the last step should be you are differentiating the things inside the bracket here. So differentiate x plus 1, we get 1. Okay, that is for the first term. How about the second term? We need to differentiate x squared. So differentiate x squared directly is equal to 2x. So now we just have to multiply, simplify everything. So this one, 1 over 2 will be the coefficient. So it will be 1 over 2 of x e to the power of square root x plus 1. And then this x plus 1 to the power of negative 1 over 2 is equivalent to, we can bring it to the bottom one because a to the power of negative n is equivalent to 1 over a to the power of n. Okay, so that's why we can put it on the denominator part. And then we have multiplied by 1, just 1. And then for the second part, second term, it will be 2 as the constant, the coefficient. So 2x of e to the power of x squared. Okay, now how can we rearrange this xe? Okay, so if you want to rearrange this, you have to follow the rules. First, usually we will arrange the coefficient, the constant, and then we arrange the x, the polynomial. So it will be constant, and then we put polynomial, and then we put exponent, and then we put log on the last part. Okay, if we have everything, so we have to use this step lah. So if we start with the constant, and then if we have polynomial, put the polynomial first, and then continue with the exponential, and then the last one will be log. So this is our final answer for question D. Okay, done. Okay, now example 2, find the derivative of the following function. So we have a, y equal to x squared multiplied by e to the power of x. And then for b, we have y equal to 2 minus x all over e to the power of x. So for this one, it's not only exponential, but we have multiplication with a polynomial x in term of x. So what we need to do? This is multiplication between two terms. So we need to apply the product rule. So what is our u? What is our v? Identify our u and v. So write down the u and v at the bottom. So we have u equal to x squared and v equal to e to the power of x. And then this is the first step. The second step is to find the derivative respect to x. So du dx equal to u prime equal to 2x, and v prime or dv dx is equal to, so differentiate e to the power of x directly, it's equal to e to the power of x. Now applying the cross-fish method, usually it's vu prime plus uv prime. Okay, it's a cross-fish. So v is e to the power of x multiplied by 2x, and then plus with u, which is x squared multiplied with v prime, which is e to the power of x. Okay, now to simplify everything, can we see any common factor? Yes, we have x on both sides. X here also have x, and then we also have exponential to the power of x. So we can factorize out these two things. So factorize out x e to the power of x. So what's left on the first part is, so we only left by 2 here, and then on the right side we have take out one x, so we have another x. That's why we have x plus 2 or 2 plus x, both correct. Okay, so this is our final answer for A. So for B, we have y equal to 2 minus x divided by e to the power of x. Okay, so this is a derivative in a form of fraction, right? So we also can see that it's actually in hard form. Bentuk love kan? So if it's in hard form, means that we can separate it. So you have two choices. Either you separate it, it will be 2 over e to the power of x minus x over e to the power of x. Or you can just let the numerator as u, the denominator as v. Okay, so if we separate it, so this one we can directly differentiate to e to the power of negative x. But x over e to the power of x, we have to apply. We still have to apply the quotient rule, because the numerator got x, denominator also got x. So it will be u over v. So it will be complicated. Why? Because we have many things to differentiate at the same time. So it's easier for us to directly using the quotient rule. Okay, so this thing we call it as analyzing the question. Okay, which method is easier, which method is faster, which method can save more time. Okay, so for this question, we can use the quotient rule better. So we separate u over v. We have u equal to 2 minus x and v equal to e to the power of x. So applying the quotient rule. First step is to recognize your u and v. Second step is to find the derivative. So differentiate 2 minus x, we have negative 1. differentiate e to the power of x will be e to the power of x. And now we just have to apply the cross-fish form. So vu prime minus uv prime. Okay, so v is e to the power of x, u prime is -1. And then minus u equal to 2 minus x multiplied by v prime e to the power of x. And divide with v squared, which is equal to e to the power of x to power of 2. And now you can simplify. Usually for quotient rule, we will use by factorization. So we look at which term we have as a common factor. So here we have e to the power of x on both sides. So we can take out e to the power of x. So on the left side we have -1. On the right side we have 2 minus x. So minus 2 minus -x. So it will be -2 plus x. Okay, so in the bracket we have -1 minus 2 plus x. So simplify, we get -3 plus x. And then for e to the power of x at the bottom, we have the power of 2. So it's actually e to the power of 2x. So at the top, sorry, not 2x, e to the power of multiplication, right? To power of, so it will be 2x. And the top we have e to the power of x. So it will be e to the power of x. If we want to bring it down, it will be e to the power of 2x. Sorry. It will be 1 over e to the power of 2x minus x. Or multiply, divide by e to the power of x. So e to the power of 2x minus x is equivalent to x only. That's why we have x minus 3 divided by e to the power of x. This is x, this is -3, right? So we can put as x minus 3 or -3 plus x, either one. So this is our final answer for question B. Okay? If you got any question, query, you can ask later. Just PM me or just ask in the lecture on the video itself. Okay. So now we continue to the derivative of logarithmic functions. So we have natural log x. So differentiating natural log x here, we will get what? So it will be 1 over x. Okay, so it's directly 1 over x for all x more than 0. So this value of x cannot be less than 0. Okay, so this is what we call as the derivative of natural logarithmic function natural log x. But the proof here is we applying the, let's say y is equal to natural log of x. So we have e to the power of y equal to x. By letting x as the subject to eliminate the log. So we have to differentiate e to the power of x. So to differentiate e to the power of x, we actually applying the implicit differentiation. So for this part, you haven't learned yet. So applying the implicit differentiation, you haven't learned that. But to differentiate e to the power of y respect to x, because it's a y. Okay, it's a y. We cannot differentiate y respect to x. So we just copy back e to the power of y and then multiply by dy dx equal to 1. So dy dx is equal to 1 over e to the power of y. What is y? What is e to the power of y? What is e to the power of y? E to the power of y is equal to, yes, it's equal to x. That's why it's equivalent to 1 over x. Okay, so this proving you don't have to remember, but this is how we find out the derivative of natural log x. Okay, so the derivative of natural log x is equal to 1 over x. Now, natural logarithmic function of the form y equal to natural log of a function fx, where fx is a sum function of x, is equivalent to 1 over fx multiplied by f prime x. So, what the difference with natural log x? It will be 1 over x, because we copy back the function inside the log as the denominator. As this one, natural log of fx, so 1 over fx. and then multiply by f prime x means that it's derivative of the fx itself. So derivative of x is equal to 1. That's why we directly get 1 over x by using this formula. Okay, so now we just have to find the derivative of fx. Okay, proving by using the chain rule. Let's say y equal to natural log of fx, then fx is equal to u equal to fx. If we let fx here as u, then y equal to natural log of u, and then what we need to do is to find du dx and dy du, because y in term of u in term of x. So derivative of u is equal to f prime x, derivative of y respect to u is equal to 1 over u, by using the formula of derivative of natural log x, it's equal to 1 over x. And now we applying the chain rule, so we get dy du, which is 1 over u, multiplied by du dx, which is equal to f prime x. So what is u? U is equal to fx. So that's why 1 over fx multiplied by f prime x is the answer. So the derivative of natural log fx is equal to 1 over fx multiplied by f prime x. Okay, so you have to put it in your notes for this formula. Now let's do some example. Example 3, differentiate the following with respect to x. So for question A, y equal to natural log of 7x plus 3. For question B, y equal to natural log of x squared plus 9x minus 4. Okay, for question A. So what is our fx in this function? So 7x plus 3 is our fx. So directly applying the formula, it will be 1 over fx, which is, this is our fx, 1 over 7x plus 3, and then multiply with the derivative of 7x plus 3. Okay, so what is derivative of 7x plus 3? So directly it's equal to 7, multiplied by 7, so it will be 7 over 7x plus 3. Okay, so this is for question A. For question B, natural log of y equal to natural log of x squared plus 9x minus 4. Okay, now what is our fx? Our fx here is x squared plus 9x minus 4. So directly by using the formula, it will be 1 over x squared plus 9x minus 4, and multiply the derivative of x squared plus 9x minus 4. So differentiate x squared, differentiate 9x, differentiate negative 4, what do we get? It will be 2x plus 9. So the answer will be 2x plus 9 divided by x squared plus 9x minus 4. Okay? So, how about example 4? Find the derivative of the following. So, for a, y equal to x cubed, natural multiply with natural log of x. So, for this part, we have x cubed. It's a polynomial multiplied with a logarithmic function. So, it's actually two terms. Multiplication between two terms. Because both have x, so we need to use the product rule. For b, we have natural log of 2x plus 3 divided by e to the power of x. Okay, so this one also we have a log function and exponential separately. Okay, so this is in the form of quotient. We need to use the quotient rule, which is u over v. So for question A, u is equal to x cubed, v is equal to natural log x. Now, applying the product rule, so we have differentiate uv equal to vu prime plus uv prime, or directly you can put the u and v at the bottom. So u equal to x cubed, v equal to natural log x. Okay, now second step will be differentiating both. So differentiate u respect to x, it will be 3x squared. So bring 3 to the front, and then the power should be subtracted by 1. So 3x squared, and then for v, differentiate v, which is natural log x, will be 1 over x. And now you can apply the crossfish form. So v u prime plus u v prime. So it will be natural log x multiplied by 3x squared plus x cubed multiplied by 1 over x. And then simplify everything. So for the second term, actually we can just simplify into x squared. So x cubed divided by x will be x squared, right? And then this x squared is actually a common factor between these two terms. So we can factorize out x squared. So what's left on the left side is 3 log natural log x. So this 3 is coefficient of log. This log x is one term. 3 is another term. So rearrange it. So put the constant in front. So 3 and then followed by the log. And then 3 natural log x plus what's left here is 1. Okay, so that's why the answer is x squared multiplied by 3 natural log x plus 1. Okay, now for B, we have to apply the quotient rule. So we have u over v. So first step is write down your u and v. So u is equal to natural log of 2x plus 3 and v equal to e to the power of x. And then for the second step, find the derivative of natural log of 2x plus 3. So this is in the form of natural log fx. So it will be 1 over 2x plus 3 and then multiply with derivative of it, which is differentiate 2x plus 3 will be 2. That's why the answer is equal to 2 over 2x plus 3. And then v prime is differentiation of e to the power of x directly equal to e to the power of x. And now what you need to do is to apply the crossfish form. So it will be vu prime, which is e to the power of x multiplied by 2 of 2x plus 3. So put the bracket, usually I will put a bracket and then subtract with uv prime, which is natural log of 2x plus 3. And then multiply by v prime, which is e to the power of x. So now we can see actually we have a common factor, which is and then don't forget to put divide with v squared. So v squared is e to the power of x to the power of 2. Okay, now the common factor here is e to the power of x. We can factorize out e to the power of x, and then what's left inside the bracket on the left side is 2 over 2x plus 3. And then on the right side is subtract by log of 2x plus 3. And all divided by e to the power of 2x. And now simplify e divided by x, e to the power of x divided by e to the power of 2x. So we can bring down the e to the power of x. It will be equal to e to the power of x only, or e to the power of negative x. We will put it on the numerator. So it depends on you lah. So you can write down also in the form of 2 over 2x plus 3 minus natural log of 2x plus 3 divided by e to the power of x. But because we have this fraction divided by a number, then it's a fraction inside a fraction. So this is not the accurate way to write down the answer. So this is cannot lah. So for this part, we need to bring up the e. Okay, so it will be e to the power of x multiplied by e to the power of negative 2x, which is equal to e to the power of x minus 2x, which is equal to negative x. Okay? Okay, so let's continue. Example 5. Differentiate the following function. So for A, we have a function of natural log of 1 minus 2x. So it's 2 times of natural log. And for gx, for question B, gx is equal to natural log of everything here. Wow, it's really complicated, right? Okay, so let's try together. Okay, so for question A, natural log of natural log 1 minus 2x, directly you can apply the formula of natural log, which is 1 over fx. So what is our fx here? Our fx here is natural log of 1 minus 2x. So 1 over natural log over 2x, natural log of 1 minus 2x, and then multiply with the derivative of fx. So the derivative of natural log of 1 minus 2x. So how to differentiate natural log of 1 minus 2x? So we need to apply back the natural log formula. So differentiate natural log of 1 minus 2x will be, it will be 1 over minus 1 over 1 minus 2x multiplied by the derivative of 1 minus 2x, which is equal to negative 2. Okay, so this is the part where we differentiating the fx earlier. So the final answer will be, so this is, okay, this one is in term of log, right? This is a log expression. But for this one, it's a polynomial. So between between log and polynomial, which one we should write down first? So it will be the polynomial first and then followed by the log. So the final answer, this negative 2 will be at the top lah. So minus 2 divided by 1 minus 2x in a bracket multiplied by natural log of 1 minus 2x. Okay, so this is our final answer for question A. So it's like an inception, log inside a log. So you have to be careful and be patient. Okay, now for question B. Okay, so the last question B, we have gx of natural log of everything here. Okay, now it looks complicated, right? If you want to differentiate directly of the logarithmic function, we have to 1 over everything and then differentiate everything. Okay, but you can make it easier. How? It's a log, right? So we can apply the law of logarithm. So this is like a multiplication between A, B divided by C. So this is A, this is B, this is C. So we can separate it by using law of logarithm, which is log of A plus log of B minus log of C. Right? This is the law of logarithm. So it will be natural log of x minus 3 to the power of 4 plus natural log of e to the power of 6x minus 5 minus natural log of square root of 2 plus 7x. Okay, now, before we continue, again, we can apply the law of logarithm. This power 4, it will be, the coefficient of the log will be 4x minus, natural log of x minus 3. And then here, natural log of e to the power of 6x minus 5. Natural log is actually log to the base e of e to the power of 6x minus 5. This power can be the coefficient, so log e is equal to 1. So that's directly we get 6x minus 5. And the last one, this power 1 over 2 is actually, this third is actually power 1 over 2. That's why if we have power of 1 over 2, we can bring it as the coefficient of the logarithm function. And now you can continue with the differentiation. So g prime x, this is gx. The next step, differentiate gx, we get g prime x is equal to 4 is the coefficient. So write down 4. And then the formula will be, this is our fx lah. Everything inside the bracket will be the fx. So 1 over fx, x minus 3. And then differentiate the fx. And then differentiate 6x minus 5. So differentiate 6, we get 6. Differentiate minus 5 will be 0. And the last term is negative 1 over 2 will be the coefficient. And then the log of 2 plus f7x will be the fx lah. So 1 over fx, which is 1 over 2 plus 7x, and differentiate the 2 plus 7x. And now do the differentiation. So we get 4 over x minus 3, differentiate x minus 3 is equal to 1, plus 6 minus 1 over 2 of 1 over 2 plus 7x. Differentiate 2 plus 7x is equal to 7. So now multiply lah. This part will be 4 over x minus 3 and then plus 6, and then this 7 multiplied by 1 over 2 will be negative 7. Will be 7 over 2 multiplied with 2 plus 7x. Okay, so this is our final answer. Okay, so anything, if you want to differentiate, you have to analyze first. What we can do to simplify the question first. Okay, so that's all for this lecture. Thank you.